Welcome to the deep dive. Today we're jumping into a really fast-moving area, 3D generation tech.
It's absolutely booming.
Yeah, specifically we're looking at Hunyuan3D 2.5 from Tencent Hunyuan. The report talks about high fidelity and ultimate details.
Strong claims.
Right, so our mission here is to figure out how this tech is actually changing the game for creating, super realistic 3D assets.
And it's such a foundational technology, really. It's a core driver for innovation in, well, so many fields.
Like what specifically?
Think about game development, film effects, VR, even embodied AI, AI interacting in virtual spaces. The ability to create high-quality 3D stuff quickly. That's becoming absolutely critical. These aren't just cool toys. They're becoming, like, essential tools.
Okay, huge implications then. So let's set the scene a bit. Before Hunyuan3D 2.5, what were the big roadblocks? What were the, let's say, pain points when trying to make really complex, detailed 3D objects?
Oh, there were quite a few. It definitely wasn't straightforward. One major challenge was just generating complexity with, fine-grained detail.
Right.
Think about trying to make a really detailed human hand or maybe a bicycle wheel with all the spokes. Older models, they often struggle to get those details right. You'd sometimes end up with geometry that looked a bit distorted or maybe too simple.
Kind of blobby.
Sometimes, yeah. And it was this constant trade-off, this balancing act between getting high-fidelity shapes that were also smooth and had sharp edges. Often, you'd get one but not the other. A smooth surface might lose the sharp detail, or a really detailed shape might look kind of jagged or noisy.
So it was like you had the rough form, but getting that crispness, the detail that really sells the realism, that was the hard part.
That's a good way to put it. And then beyond just the shape, the geometry, texturing had its own set of significant problems.
Okay.
Older methods often had trouble creating textures that looked consistent from different viewpoints. You'd spin the model around and maybe see visual artifacts like weird seams or colors shifting unexpectedly.
Almost like wallpaper that didn't quite line up.
Kind of, yeah, as if the texture was just sort of slapped on without really understanding the 3D shape underneath. And for true photorealism, you really need physical-based rendering PBR materials.
Right.
These define things like how metallic something is or how rough the surface texture is. That dictates how light actually interacts with the object. And there just wasn't a great selection of open source tools for generating those complex PBR materials automatically. And that made it tough for smaller teams or individuals to get those really high-end results.
Okay, so that lays out the challenges pretty clearly. How does Hunyuan3D 2.5 actually step in to address these specific long-standing issues? What's their strategy?
Well, Hunyuan3D 2.5 uses a pretty robust two-stage pipeline. It's designed specifically for generating these high-fidelity, detailed, textured 3D assets. It definitely builds on their earlier work, Hunyuan3D 2.0 and 2.1, but it introduces some key new ideas.
A two-stage pipeline, so like an assembly line.
You could think of it that way, yeah. First, you start with an input, maybe an image of the object you want. That image gets processed a bit. Then, stage one kicks in. That's a dedicated shape generation model. Its job is to create the underlying 3D mesh, the basic geometry.
Okay, the skeleton.
Kind of. And once that mesh is created and refined, stage two takes over. This is a separate texture generation model, and it applies all those detailed, realistic PBR textures we were just talking about.
That breakdown makes sense. Let's dive into stage one then, the shape generation. They introduced a new foundation model here called LATTICE. What's the innovation with LATTICE? Why is it better at shapes?
LATTICE is a pretty significant step up. It's what's called a large-scale diffusion model.
Okay.
So it learns to create complex things by sort of starting with noise and gradually refining it into the desired shape, a bit like sculpting. But the key thing with LATTICE is its sheer scale. It was trained on huge, high-quality 3D datasets. And Tencent Hunyuan really invested in model size and the computing power behind it.
How big are we talking?
Well, the largest version of LATTICE apparently has 10 billion parameters.
10 billion. Wow. What does that actually buy you in terms of the final 3D shape? Does that scale really translate?
Oh, it makes a huge difference. That scale allows LATTICE to generate shapes that are remarkably sharp and detailed. And importantly, it's very good at what they call image to 3D following. So if you give it a complex 2D image, it can translate that complexity accurately into the 3D geometry. And it does this while keeping the mesh surface itself, clean and smooth. This is a big deal because it starts to really close that gap between AI-generated shapes and the kind of meticulous work a human 3D artist does.
So fewer weird artifacts like those strange hands you sometimes saw. You mentioned extreme detail earlier. Can you give some concrete examples of what LATTICE can do now that was tough before?
Sure. Think about a human hand again. Getting the right number of fingers, making them look articulated, that was often a problem area. Lattice can generate the correct number of fingers with convincing individual detail.
Okay, that's impressive.
Or take that bicycle wheel example. Lattice can reproduce those intricate spoke patterns accurately, where older models might have just produced a sort of blur or a simplified mess. Even something subtle, like correctly rendering a small bowl sitting inside a larger scene, shows it can handle both the overall structure and the tiny details at the same time.
And it balances the smooth surfaces with sharp edges. That was the trade-off you mentioned.
That's right. Achieving that balance was a major hurdle. Lattice seems much better at maintaining smooth areas where needed, but also creating crisp, sharp edges where the geometry demands it. It's less of an either situation now.
That's fantastic for the underlying shape. But like we said, realism needs more than just geometry. It needs that surface interaction with light. So the next step is texturing, right? Hunyuan3D 2.5 uses PBR. What does that upgrade really mean for the textures?
Yeah, PBR is absolutely key for believable results. You can think of PBR as providing the rules for how light should bounce off every single point on that 3D surface. It's not just about the base color. It defines, how shiny is it? How rough is it? Is it metallic? Does light scatter or reflect sharply?
All those subtle surface qualities.
Exactly. So Hunyuan3D 2.5 uses a new material generation framework. It builds on their previous multi-view PBR architecture, but it's enhanced. What it does now is generate multiple maps simultaneously from different viewpoints: an albedo map, a roughness map, and a metallic map.
Can you quickly define those? Albedo, roughness, metallic.
Sure. So albedo is essentially the pure base color of the surface, kind of imagined under perfect neutral lighting, no shadows or highlights baked in.
Okay.
Roughness controls how light scatters. Low roughness gives you a shiny mirror-like reflection. High roughness gives you a dull, matte look where light diffuses more.
Got it.
And metallic, well, that determines if the surface behaves like metal, which fundamentally changes how it reflects color and light compared to, say, plastic or wood. And these maps are generated following the principled BRDF model. That's the bidirectional reflectance distribution function. It's the physics-based math that accurately describes how light reflects off surfaces. The whole goal here is to precisely capture that surface reflection behavior and simulate the tiny microsurface details that make materials look real under different lighting.
So it's not just painting color on, it's teaching the model how that surface should react to light, almost like giving it material science rules.
That's a really good analogy, and technically, how they do it involves using learnable embeddings for these maps, albedo, and then a combined metallic roughness map, or MISIS. These embeddings are like smart, compressed ways the model learns to represent and generate these complex material properties. They also mention a dual-channel attention mechanism with a shared attention mask. You can sort of picture the model having two ways of looking at the texture. Maybe one focuses on color, one on roughness metalness. The shared mask ensures both eyes are perfectly aligned, looking at the exact same spot on the model, so the different material properties line up correctly across the surface. No weird sliding or misalignment?
That sounds complex, but important for consistency.
Very. And to handle all this detail without needing impossible amounts of computer memory, they use a clever dual-phase resolution enhancement strategy.
How does that work?
Phase 1 is more conventional, training using multiple views, like 6 views, at a moderate resolution, say 512 by 512 pixels. This builds a solid foundation for consistency, making sure the object looks right from different angles. Then, Phase 2 uses a zoom-in training strategy. This lets the model learn extremely fine texture details without needing to train everything at super high resolution all the time.
Like focusing on specific patches.
Kind of, yeah. It allows it to learn intricate details more efficiently. Then, when it actually generates the final texture, it can leverage higher resolution views up to 768 by 768 to produce those really detailed results.
That's a very sophisticated pipeline.
Right.
Okay, the tech sounds impressive on paper, but how does Hunyuan3D 2.5 actually stack up in practice? What did the evaluations show when they compared it to other methods?
The results look pretty strong based on their report. They did extensive testing, quantitative metrics, qualitative comparisons, and also user studies, which are really important. The main takeaway seems to be that Hunyuan3D 2.5 significantly outperforms earlier methods, both in the quality of the shape generation and in the final textured result. And this comparison includes not just older models, but also current state-of-the-art open source options and even some well-established commercial closed source systems.
So we're talking a noticeable jump, not just a small improvement over the best that's currently available.
That seems to be the case. The visual comparisons in their paper really highlight the difference. You can see more detail in the shapes and more realism in the textures compared side by side with competitors. And the user studies really back this up. For the image to 3D task, where people judge the quality of the 3D model generated from a picture, Hunyuan 3D 2.5 apparently had a 72% win rate in head-to-head comparisons.
72%, that's substantial.
It is. And they mentioned this was 9 times higher than the win rate of one leading commercial model they tested against.
9 times.
Yeah.
Wow. What was it that the other models were struggling with that Hunyuan 3D 2.5 seems to handle better?
Well, according to the report, a key area where competitors often fall short is in accurately estimating those PBR values, the metallic and roughness properties we talked about, and also in properly separating the intrinsic color, the albedo, from the effects of lighting in the source image. If a model can't do that well, the resulting textures won't look right under different lighting conditions in a new scene. Hunyuan 3D 2.5 appears to be much better at handling these aspects, leading to that more convincing photorealistic look. It suggests a deeper understanding, if you will, of how light and materials actually behave.
Right. So pulling it all together, the core strength here seems to be this major leap in creating 3D assets with both high-fidelity shape and incredibly detailed, physically plausible textures. We're getting closer to generated assets that are hard to tell apart from handcrafted ones.
It really feels like a significant step in that direction. The ability for models like this to generate such precise and realistic digital assets, well, it's changing content creation workflows. It just keeps pushing the boundaries for visual realism, whether that's in games, virtual worlds, simulations, you name it. This kind of progress really reshapes how we think about building digital experiences automatically.